One last topic to look at in this PPT, which is detectors. So generally I'll explain the broad outline of how a detector works, and then we'll look at some of the types and properties. So for a detector, you usually have a semiconductor diode. You have a P region and an N region. The holes and electrons come and combine. Now when your light comes and falls on a detector, this combination of holes and electrons gets activated on seeing that light. They get energized sort of, and they absorb that light. So they absorb the information which is stored in that light, and then this electron hole pair is then sent, containing information in the form of light energy, is then sent to a restorer, and there some electronics takes place which converts it back into analog or digital signal. So that is the basic idea of a detector. You have a semiconductor, a P region and an N region. The electron and hole combine in the presence of light. They light, as in the light coming from your fiber optic cable, they take up that signal and then they go to the restorer and the signal is restored. So what are the different types of detectors we have? PN diode is your normal semiconductor, P region, N region, which works just the way I explained right now. Then you have PIN diode, P intrinsic region, N. So you have a P region and an N region as we have in our normal diodes, but in between both you have a region of an intrinsic semiconductor. Intrinsic meaning pure, like silicon, gallium, one which has not been doped. So what this does is, so you have holes on one side and electrons on the other side. When you have this intrinsic region, it starts attracting both. It acts almost like a magnet attracting iron nails. This intrinsic region starts attracting electrons as well as it attracts holes. So more electrons and holes are pulled into this region, more of them combine. So when the light falls on them, more electron hole pairs are available to pick up the light signals. So the signals are essentially transmitted in a more effective manner. When the greater the number of electron hole pairs you have, the better the information is going to be transmitted, because each ray of light is going to be attended to by a larger number of electron hole pairs. So every bit of information will be properly individually received and transmitted and restored. So that intrinsic region in between, by acting like a magnet, it helps you increase the number of electron hole pairs. That is what you have the PIN diode for. And then the avalanche photodiode, what it does is, again you have one P region and one N region. The electrons, the holes, they come and combine, and when they combine, this avalanche photodiode is made of such a material where the energy of recombination is very high. So what happens is, when they combine, they give out a lot of energy. That energy hits on the neighboring electrons and holes. They also get excited, so they also enter this region and they start combining. So again you have more electron hole pairs, so the light is going to be received and transmitted better. So the idea of both PIN and APD is to increase the number of electron hole pairs you have, so that signals can be received in a better way. PIN does it by introducing an intrinsic region which sort of acts like a magnet. APD does it using the avalanche effect, where one electron combines with a hole, it gives out a lot of energy, and the other electrons are sort of, they rub off that energy and they also combine with holes, and thus the process continues. So this is an important tabular column, so I want you guys to pay a little attention. You might get match the following, those type of questions from here, 3 marks, 6 marks and all that. So this talks about the different types of diodes. This is the wavelength of light which they work. Dark current, you can assume, is the current they consume. So for a diode you need to provide a voltage, right? Either forward bias or reverse bias. These diodes usually work on reverse bias, and the current which they consume in reverse bias is called the dark current. Responsivity amperes per watt is the amount of light they take up per watt of power, the amount of current they consume per watt of energy. And rise time is the time taken for recombination, like how much time in nanoseconds does it take from the point where I provide electricity or voltage to the point where the hole and electron recombine and take up light. So the response time sort of. So these values I would recommend you to learn if possible, and even if not, Remember the idea of PIN diode, PIN and APD.